Welcome back, viewers. How do we determine the diameter of the small semicircle? Now here the small semicircle is the blue region. Now the best way to determine this diameter of the small semicircle is to make this figure a complete circle by flipping it vertically, and we'll have, so if we flip it, we'll have the figure will now be a complete circle. Let us label these points at the circumference to be A, B, and this to be X, to be XY. Now this figure is a completing circle, and you can see AB is a chord and XY is a chord, and they are intersecting at the center of the smaller circle. So if we let the center of the smaller circle to be O and the radius of the smaller circle to be R, meaning this length will be R, here will be R, that will be R, that will be R. So what is the relationship between intersecting chords? Meaning the distance from A to O times the distance from O to B will be equals to, from A to O times from O to B will be equal to the distance from X to O times O to Y. X to O times O to Y. That is the relationship between two intersecting chords. You can see the two chords are intersecting at point O. Point O is in the middle in each case. So let us substitute the values. So here AO, from A to O is 18 plus R. So that is going to be 18 plus R. Then it is times from O to B. From O to B is R plus 4. That is R plus 4 to be equals to, from X to O. Now from X to O is 10 plus R. That is 10 plus R. Then it is times from O to Y. From O to Y is R plus 10, which is still the same as 10 plus R. Now, what do we now have here? 18 plus R times R plus 4. So 18 plus R times R plus 4, you'll get 18 times R will be 18R, then 18 times 4, that will be 72, then plus R times R will be R squared, then R times 4 will be plus 4R, to be equals to 10 plus R times 10 plus R is like 10 plus R squared. So that will give you 10 times 10 is 100, 10 times R is plus 10R, R times 10 is again plus 10R, then positive R times positive R is plus R squared. You can see R squared is common on either side of the equation. So R squared will cancel with R squared. So what do we remain with? On this side we have 18R plus 4R is 22R, then plus 72 to be equals to, this is 100, 10R plus 10R, that is going to be plus 20 plus 20R. So if you collect the like terms, plus 20R coming this side, you will have 22R minus 20R to be equals to 100 plus 72 going on the other side is going to be minus 72. So 22R minus 20R is going to be 2R to be equals to 100 minus 72 is going to be 28. So remember, you were told to determine the diameter of the smaller circle, and remember the diameter is 2R. So that implies that the diameter of the smaller circle is 28, because diameter is 2R, and we found 2R is 28. So the diameter of the smaller circle is 28. Ladies and gentlemen, that is the simplest means to determine the diameter of the smaller circle, of the smaller semicircle, is by making it a complete circle, so that you can use the concept of intersecting chords. Thank you for watching, and see you again in our next video. Welcome back to our channel, ladies and gentlemen. Now, how do we determine the red area of this radical geometry problem. So if we transfer this problem into the whiteboard, we will have the red area is the area of the circle minus the area of the triangle. So since the two sides are equal, we can drop a perpendicular bisector in that manner. So if we label this diagram, we let this to be A, B, C. Then since the side BC is equals to the side CA, meaning this length BA is divided into two equal parts, so 6 is going to be divided into 3 and 3. So if you let the perpendicular height to be H, then this angle at vertex A to be angle A, then we can use the sine rule. So if this is angle A, the opposite side is going to be denoted by small a. If this is angle B, the opposite side is going to be denoted by small b. If that is angle C, then the opposite side is small c. Now if you use the sine rule, we have A over sine A to be equals to B over sine B to be equals to C over sine C to be equals to 2R. Now we can use any. So if you start, for instance, sine A, because this is a right angled triangle, sine A is going to be given by opposite over hypotenuse. So you can see the opposite is the height h. So the opposite is h over the hypotenuse is CA, which is 5. So we have sine A is h over 5. And how do you get h? If you take this right angle triangle here, if this side is 3, this is 5, then meaning h is 4 according to Pythagoras theorem. H is simply the square root of hypotenuse squared, which is 5 squared, minus the other shorter side squared, which is 3 squared. Then you get it to be 4 because of the right angle triangle C. Maybe if you let that point OCOA. So h is 4. So if h is 4, then it is a clear indication that sine A is h over 5 is 4 over 5. So if sine A is 4 over 5, then we now have A over sine A over sine A should be equals to 2R. So if you substitute the side A is 5, so that is 5 over sine A is 4 over 5 to be equals to 2R. So there you'll get 5 times 5 will be 25 over 4 to be equals to 2R. So if you divide both sides by 2, then you are supposed to get R. When you divide both sides by 2, you get R is 25 over 8. 2 goes with the 2. You remain 25. 2 times 4 is 8. So R is 25 over 8. Now, having found the radius to be 25 over 8, so how do we get the red area? Now, the red area is very simple. It is the area of the circle, which is pi r squared, minus the area of the triangle, which is a half base times height. So what is that? That is pi. R is 25 over 8 squared. Then minus a half base times height. So you can see the base is from B to A, which is 6. Then the height h we found to be 4. So what do we get to be the red? To be the red area, 25 squared, that is 625 pi over 64. 8 squared is 64. Then it is minus a half of 4 is 2 times 6, 12. So it means the red area of this radical geometry problem is 625 pi over 64 minus the area of the triangle. The red area is the area of the circle minus the area of the triangle. Ladies and gentlemen, that is the simplest trick to deal with that radical geometry problem. Thank you for watching and see you again in our next presentation.